If a predator grabbed you right now, what would you do? Run? Fight? Scream? Maybe freeze. Those are basically your only options. But somewhere in a tide pool right now, a sea cucumber is doing something you'd never think of. It's shooting its own internal organs out of its body at the animal trying to eat it. And it's not even the strangest defense in the animal kingdom. Not close. Today, we're looking at the weirdest, most inventive, most how did evolution even land on this ways animals protect themselves, and what they reveal about the actual rules of survival. Most defenses fall into categories we understand instinctively: speed, size, teeth, claws. A gazelle outruns a cheetah. A rhino is too big to bother. These make sense to us because they map onto our own instincts, fight or flight. But evolution doesn't care what makes sense to us. It only cares what keeps an animal alive long enough to reproduce. And once you take away the assumption that defense has to look like fighting or fleeing, you get some genuinely bizarre solutions. Start with the hagfish. It's an eel-like scavenger that lives on the ocean floor, and it has almost no natural weapons, no claws, weak jaws, slow movement. So when a predator bites down, the hagfish does something else entirely. It releases a burst of fibers that react instantly with seawater, expanding into a cloud of thick, sticky slime. Enough slime that the predator's gills clog, and it has to let go or risk suffocating. The hagfish isn't fighting, it's not fleeing, it's making itself physically impossible to eat. This is where it gets stranger. Some animals defend themselves by giving up something. The most familiar example is a lizard dropping its tail. The tail keeps wriggling on the ground after it's detached, distracting the predator's attention while the rest of the lizard escapes. The lizard survives, regrows the tail over weeks, and lives to reproduce. Now push that idea further. The sea cucumber mentioned earlier takes self-sacrifice to an extreme most animals wouldn't dare. When threatened, some species contract violently and expel a portion of their internal organs, sticky, toxic tubules called Cuvierian tubules, directly at the attacker. The threads tangle and irritate the predator, while the sea cucumber, missing a chunk of its own digestive system, slowly crawls away. Over the following weeks, it regenerates the organs it lost. It's a defense so extreme it looks almost self-destructive. But biologically, it's the same math as the lizard's tail. Losing a piece is always cheaper than losing everything. Some animals don't sacrifice parts of themselves. They turn their own physiology into a weapon. The bombardier beetle stores two separate chemical compounds in its abdomen. On their own, they're harmless. But when the beetle is threatened, it mixes them in a specialized chamber, triggering a violent chemical reaction that shoots out boiling, corrosive spray, audibly in a rapid popping burst, aimed with startling accuracy at whatever's attacking it. Then there's the electric eel, which isn't actually an eel at all, but a fish capable of generating electric discharges strong enough to stun prey and deter predators. Specialized cells called electrocytes stack in the eel's body like tiny batteries wired in series, so when the eel fires, thousands of these cells discharge at once. What's notable about both of these isn't just the mechanism, it's the specificity. These aren't generic toxins or spikes, they're precision systems refined over millions of years, doing one job extremely well.
Not every defense is physical. Some are pure performance. The Virginia opossum is famous for playing dead, but it's not a choice. When sufficiently threatened, the opossum enters an involuntary catatonic state. It collapses, its lips curl back, its breathing slows, and it can even release a foul-smelling fluid to mimic the smell of a rotting carcass. Many predators are wired to avoid food that already looks and smells dead. It's a signal of disease. So the opossum's performance exploits the predator's own instincts against it. Compare that to the mimic octopus, which can rearrange its body shape, color, and movement to imitate other, more dangerous animals, flattening itself and undulating like a venomous sole, or tucking its arms to mimic a sea snake. It's not just camouflage, it's active impersonation, chosen based on which predator is nearby. This is where the psychology of researchers like the Kellogg's becomes relevant. Decades ago, they famously raised a chimpanzee alongside their own infant son to study how much behavior is learned versus innate. What they found, and what later research on animal cognition reinforced, is that a huge amount of behavior we assume is thought through is actually deeply wired instinct, automatic responses shaped by generations of trial and error, not conscious decisions in the moment. The opossum isn't deciding to play dead any more than you decide to flinch. Its body does it for it. Some of the strangest defenses aren't a single dramatic move. They're constant, low-level strategies running in the background at all times. The pufferfish inflates by rapidly gulping water, more than doubling its size in seconds, turning a slow, awkward swimmer into a spiky ball too large and dangerous to swallow. Many species also carry tetrodotoxin, a neurotoxin potent enough that a single pufferfish can carry enough to be lethal to multiple adult humans, meaning even a predator that does get a bite in may not survive the meal. Subtle fish, meanwhile, run camouflage almost continuously. Specialized skin cells called chromatophores let them shift color and pattern within a fraction of a second, matching their surroundings so precisely that they can disappear against coral, sand, or rock in real time. It's not a single defensive event, it's a constant, low-grade arms race against every predator that might be watching. Step back and look at all of these side by side: the hagfish's slime, the sea cucumber's organs, the beetle's chemistry, the opossum's performance, the cuttlefish's constant camouflage, and a pattern emerges. None of these evolved because they were clever. They evolved because, over millions of generations, they worked. Every single one is a solution to the exact same problem every living thing shares. How do you keep existing long enough to pass your genes forward? Humans like to think our defenses are different, that our fight or flight response, our fear, our instinct to freeze in a crisis are somehow more sophisticated than an octopus impersonating a sea snake. But biologically, they run on the same underlying logic. Adrenaline flooding your system before a car swerves towards you, freezing during a moment of danger before you even register the threat. These are our version of the same ancient toolkit, just refined for a different environment. The weirdest part of studying animal defenses isn't the slime or the exploding organs or the electric shocks. It's realizing that every strange, extreme, seemingly illogical strategy is actually the same rational answer, evolved independently, over and over, across millions of years and thousands of unrelated species. Survive by any means necessary, even if it means giving up a piece of yourself to keep the rest alive.